The stakes could not be higher. If we ignore these clues, we risk missing the first real evidence of extraterrestrial life and letting others take the lead in the new space race. Scientific glory, national prestige, and future access to Martian resources all hang in the balance. These sediment layers are not random. They echo the signature formations sculpted by persistent waves, hinting at a shoreline touched by an immense body of water. If these layers are truly what they seem, Mars may have once hosted a vast ocean, stretching across much of its northern hemisphere and lasting for millions of years. What if Mars once boasted real, rolling waves and sandy beaches, just like Earth? It sounds unbelievable, but new evidence suggests this is more than just wishful thinking. Chinese scientists, using the Zhurong rover's ground-penetrating radar, have discovered inclined layers beneath the Martian surface that look strikingly similar to the ancient beaches found on our own planet. This is not just about scattered ice or the faint scars of dried-up rivers. We're talking about a stable, long-lived ocean environment, one that offered chemistry, energy, and maybe even the conditions for life to begin. If this interpretation holds, it does not just rewrite Mars's history, it challenges everything we think we know about how planets evolve and where life might find a foothold. But how did a layer of Martian dust give way to a buried coastline? Let's retrace the journey that turned a scientific gamble into a potential planetary game-changer. But the rules of the game were about to change. A bold new mission from a rising contender would soon upend everything we thought we knew about Mars. For centuries, Mars has teased us with hints of a wetter, richer past. From the first telescopic glimpses in the 19th century, people imagined a world of canals, dried-up seas, and even alien civilizations clinging to life along forgotten shorelines. The red planet became a canvas for our hopes and our questions about life beyond Earth. With one daring landing and a powerful new tool, the search for Martian water and for ancient life was about to yield its most dramatic evidence yet. But as science advanced, the dream seemed to dry up. Probes and landers revealed a cold, barren, and wind-swept landscape, dusty plains and ancient craters under a thin, hostile sky. Still, Mars never fully gave up its secrets. The battered surface showed valleys that looked suspiciously like old riverbeds, and scientists found minerals that only form in the presence of water. For decades, these tantalizing clues kept the hope alive. Maybe, just maybe, Mars once had real open water. In 2020, China gambled everything on an unprecedented, all-in-one Mars mission, staking not just national pride, but their scientific future on the outcome. Yet, something essential was always missing: a smoking gun. We found hints and scattered signs, but never unambiguous, direct evidence of an ocean. No ancient beaches, no unmistakable shoreline, nothing to prove that Mars was once blue instead of red. Until now, the whole idea of Martian oceans, and by extension, Martian life, was more myth than certainty. And that uncertainty has shaped everything: where countries send their probes, how billions in funding are spent, and which nation claims the spotlight in the search for life. Unlike anything attempted before, the Tianwen-1 mission launched an orbiter, a lander, and the Zhurong rover together, making China the first nation to attempt this audacious triple play on its maiden voyage to Mars. The goal? To land in Utopia Planitia, a vast flat plain in the northern hemisphere, long suspected of concealing hidden ice and holding exceptional scientific value. With this single mission, China vaulted into the top tier of Martian exploration. Success would mean global scientific credibility and a massive leap in engineering prowess. But failure would have set back China's ambitions, with enormous costs and a loss of international standing. The stakes could not have been higher. Touchdown in Utopia Planitia was a high-wire act. The region was not just chosen for safety, but for strategy. If Mars ever had a true ocean, this would have been its shoreline. But the real technological leap rode with the Zhurong rover itself. As it rolled across the Martian surface, Zhurong deployed a powerful ground-penetrating radar, constantly scanning beneath the red dust, layer by layer, meter by meter. Yet the implications go even further than technical mastery. They force us all to rethink what Mars was and what it might still become. Then, breakthrough. About 10 meters below the surface, the radar revealed something stunning. Smooth, inclined layers of sediment stretching further than expected, perfectly matching the shape and order of beaches formed by waves here on Earth. These deposits extended to depths of up to 35 meters and were far too organized to be the handiwork of wind or volcanic flows. Instead, the patterns matched what scientists see on ancient shorelines. A clear sign of water lingering for ages, building up Martian beaches just as oceans do on our world. If these truly are ancient Martian beaches, what does that say about the planet's habitability? And what secrets could still lie buried beneath the red sands? The search for life takes on a new, urgent edge. If Mars truly once hosted a stable ocean, the ripple effects shake the foundations of planetary science and force us to rethink where life might emerge in the cosmos. For beaches to form, Mars could not have been the frigid desert we know today. It must have been warmer, wetter, and wrapped in a much thicker atmosphere, a world that might have looked strangely familiar, not alien at all. This paints a picture of ancient Mars as a planet where blue waves lapped against sandy shores for millions of years. On Earth, coastlines are more than scenic, they are the engines of life's origin. Primitive microbes first flourished where nutrients, sunlight, and water mixed in ever-changing combinations. If Martian beaches existed, they might have offered the same fertile ground for life to spark, adapt, and evolve. What makes these beaches even more tantalizing is their potential to preserve the past. Fossilized Martian shorelines, now buried beneath dry sand and dust, may have locked away ancient biomarkers, molecular fingerprints of life, sheltered from the relentless radiation that bombards the surface today. If these traces exist, they could survive for billions of years, waiting for discovery. Yet, we have not reached absolute proof. We do not have a Martian rock, rich in ancient organics, to examine in our labs. But the signals line up. Ground-penetrating radar, high-resolution topography, and realistic sediment models all point to the same story. The weight of evidence is becoming impossible to ignore. This stunning revelation has triggered a new kind of space race. A fierce competition, not just for knowledge, but for leadership and discovery on the red planet. The true battleground? It is not who reaches Mars first, but who brings its secrets home to Earth. If we dismiss these clues, we risk missing life's traces entirely and spending billions of dollars and years of effort chasing the wrong questions or exploring the wrong places. The stakes are not just scientific. They are about our place in the universe, the value of future missions, and the resources that might one day fuel human expansion. This moment is about far more than national pride. The first samples brought back could answer the biggest question of all. Did Mars once support life? And beyond the search for ancient microbes, the analysis of these rocks may reveal something even more practical. Hidden resources like water ice, potential fuels, and safe landing sites for the next wave of explorers. With China's recent discovery of ancient Martian beaches, the stakes for the next phase of Mars exploration have skyrocketed. China is preparing to launch its own sample return mission as early as 2028. Meanwhile, the United States and Europe are aiming for the mid-2030s. The race is on, and whoever returns Martian rocks to Earth first will claim unmatched scientific prestige and influence the direction of future Mars missions. Those newly discovered fossilized beaches, deltas, and shorelines are not just scientific treasures. They are rapidly becoming the new map, prime targets for sample collection, future resource extraction, and, possibly, the first human landings. These sites could offer the safest terrain, the richest chemistry, and the best shot at finding preserved biosignatures. The outcome of this Martian race will shape the very future of space science and geopolitics. The nation that wins will not only set the global agenda for Mars, but may also lay the foundation for a new space economy based on the resources revealed beneath those ancient Martian shores. What if the universe's biggest question fits inside a single tube of Martian sand? But beneath every discovery lies a deeper layer of questions. What exactly will we find when those first samples arrive? And how might they change our understanding of life itself? Ultimately, Mars's buried beaches are not just a challenge for scientists and engineers. They are a challenge for all humanity, demanding that we rethink our place in the universe and what we are willing to do to explore it. Because maybe, after all the engineering, the calculations, and the decades of risk, the true treasure on Mars isn't a fossilized beach or a line in a research paper. It's the story that grain of sand can tell, a story about how worlds are made, how they die, and maybe how life begins again. That's the risk and the promise. Will the answers we find in Martian sand redraw our map of life in the universe? Or will they unsettle everything we thought we knew about planets and ourselves? The Zhurong rover's radar didn't just reveal ancient beaches. It cracked open a door to a time when Mars was blue, restless, and possibly alive. Suddenly, every sand layer, every ripple under the dust, is a clue whispering about lost tides, vanished storms, and the chemistry that could have kindled life. But this isn't just about history. The search for Martian oceans is now a race for meaning, a contest that pulls in science, technology, and national ambition. Whoever brings home the next sample from Mars won't just win prestige. They'll shape how humanity understands its place in the cosmos and decide which country gets to write the next chapter of space exploration. The real mission isn't just to gather more data. It's to see every speck of Martian dust as a message from another world, waiting to be decoded. And in doing that, maybe we'll unlock not just Mars's secrets, but our own.